DISSco is a distributed system of scientific collections. So today I will briefly give you some high-level overview and some technical introduction. And if you're interested in more details, here are a few links, our webpage, blog, and some of our activities in GitHub that you can follow along. And I'm currently working as a data architect at Naturalis in Leiden. Naturalis basically leading the DISSco project at the moment with several other European partners. So what is DISSco? The goal is to digitally unify the fragmented landscape of the natural science collections. And when we talk about natural science collections, we mean all the natural history museums, herbariums, and different other research collections around Europe. And these collections host all sorts of physical objects, specimens, collection materials, manuscripts, and we've been doing that for the last 200 years or so. So there's enormous amount of objects there, and these objects not are just for display, for education, they're amazing scientific resources for not just biological science, for all sorts of different disciplines. So the idea is sort of digitally get this fragmented landscape together under one curation process, policy, and practices. As you can see here, we're working with 170 plus national facilities, and more organizations are interested to join our consortium across 23 different countries, sort of to create this one big virtual European collection. Why do we need this? So the reason this project came about, and we're also in the S3 roadmap, which is the roadmap for some of the research infrastructures. Of course, digitization and some of this IT-related things within our domain is not new. We've been doing that for a long time. However, the current model, in a way, is slow because all of these physical objects need to move around for various research purposes. The researchers need to move around. There's lack of coordination and fragmentation within how some of this scientific data moves and scientific data request comes. And of course, a lot of this physical access limits the way you can do things in a broader scientific disciplines. So we want to change that in an integrated research infrastructure model, provide wider access, and this integration hopefully will lower costs and will make research procedures faster, provide new insights with all this digitization and digital models. And of course, fair, findable, accessible, interoperable, and reusable is also a key element to this integration. So where are we now? We're currently in our preparatory phase. We're not a ERIC yet. We're still a Horizon project. And we're going towards our sort of construction and operation phase in the next few years. However, there are a variety of different related projects that has been happening in the last few years that's been producing different services already. We have a lot of prototypes and demos and proof of concept coming in. And of course, in different European projects when we're working, we're also producing things that will go towards the big research infrastructure preparation. So a lot to look forward to in the next few years, but also a lot of things happening, but I'll talk about those in a minute. So here's the sort of the big concept that we're working with, and this is also in a way similar to the digital twin type idea. As I mentioned, all these physical objects we have in our collections around Europe, almost the estimate is 1.5 billion physical specimens. And of course, digitization is happening, but we want to take that digitization, analysis, and computation to the next phase with the fair digital specimen. And the idea is that not just have a digital entity or digital representation, make that digital representation an actionable knowledge unit. And I'll show an example what we mean by that in a minute. So it's more than just creating a web page, more than just getting a picture. We want to connect it with different data sets, different types of operations, and expand this collector of this information in a different domain. And this is happening in the conceptual planning for this happened in the last few years. However, there are policies and standards in place that helps us curate the physical specimen data. There's already a variety of different data standards. There's different ways of digitization and workflow. All of these things with the existing practices, we want to bring it to sort of next level in this digital object architecture level with the idea of digital specimen. And particularly, I'll give an example in a minute about how we use the persistent identifiers and metadata for all these objects to connect them with other data classes, workflow, and doing different sorts of scientific operations on them. So the key thing to remember is that, of course, we're not starting here from zero. You know, we have histories and policies and tenders that we can reuse, but at the same time, you know, we need to think about the next levels of operations and policies as well. And one way we're doing this is a sort of a wide array of global consultations and discussions. We started with our concept of digital specimens several years ago. And at the same time, from the research domain, especially from the US, there was a lot of talk about digital extended specimens, and particularly when you collect an object, a sample, how do you collect data, look at the object and the extension of those objects around it. And from all those discussions and also the discussion around fair digital object architecture, you know, we came up with sort of this conceptual framework of how to think about digital specimen and digital extended specimen. So this is a very simple abstraction here, and there's a paper recently came out. You can find the link here as well. And again, the idea is to describe these physical objects in the digital realm with a persistent identifier and a specific type of metadata. And I'll give an example soon, where you have some core primary specimen data, but at the same time, there will be derived information, associated information related to the specimen, also media images and things like that. And the whole idea of extension is that we take these physical objects and take it to different links and different operations that might be related, derived, or not stored in the same place. So there's also a distributed aspect of that. However, this PID, this persistent identifier, is the key to get you to the information you need. And of course, there's always this connection with the physical object that we have in our collections. So this is, again, similar to, in a way, you can think about a digital twin as well, the physical and the digital sort of connecting together, or at the same time, the digital realm is also being evolved and dynamic. And we're building these digital specimens and other things, and we're using them as building blocks for the services that we're planning. So at the bottom, you see the physical specimen and the digital specimen and the details for each of them, each of the objects. And then, of course, some of these objects are aggregated in different fashions, you know, either through geological time or preservation, different dimensions of the collection holdings. And all of this provide a structural overview of all these collections that the institutions have. And we want to do that in a wider European collection fashion. So quickly people can find out what has been digitized, who has what, in what digitization level, and how that connects to other different types of services, not just DISSco, other services as well. So some of the DISSco services we're looking into will have integrated entry point for people to find these objects and the digitalization level, and they can request them. They can also help them to curate and annotate these things. There's will be a lot of different types of data refinery system, dashboards, knowledge base, and of course, different sorts of new e-services will be coming along based on these components. Here are a little bit more details about some of these services, what they will do, and we can categorize them in three sections. Of course, we have the objects and the derived data. There's also people and access, both physical and virtual access, and of course the organization and the structure that connects all of these things. So on the specimen side, as I mentioned, there will be a repository of all these specimens that will have the persistent identifier connected with that, and we're already doing a lot of design work for that system in a separate European project, but well connected to DISSco and several other international partners. Basically build a system where each of these digital specimen will get a DOI. And of course, after DOI, after the metadata, we want these objects to be dynamic. We want human experts and machine to come and enrich this data, annotate the data. So a wider community curation model. And those annotations we also want to store as fair digital objects. And that's kind of makes that specimen data much more interesting and dynamic. But you need people to do that. So there are systems we're already working on where people can come and register with their ORCID ID. And there's authentication and authorization system we're working with that will help people to use single sign-on and federated authentication. At the moment, the Elvis system is used to register transnational access and virtual access calls and requests. So these are the services currently happening through various European grants where researchers can request to visit a museum or collections. And then the review panel looks at those collections based on the capacity and resources and grants those access. So at the moment, these are happening through grants and calls. However, within the scope of DISSco, when DISSco will be operational, this will become a full-fledged service. And the way we are looking into identifying this organization is through another persistent identifier called ROR ID that uniquely provides a link to the institutional metadata and of course takes you to the institutional webpage. Because oftentimes we see different ways of describing the institution that creates problems. So we want to solve that with these ROR ID as well. We're also working on documentation, knowledge base, and of course, there's a lot of data modeling works happening behind the scene to make all of these services work. Here's a quick example of how data enrichment could work, in particularly in a automated and machine-enabled operation. So on the left, you have the digitized image of a herbarium specimen. This is a leaf. This is a very typical way of preserving these materials. And you have all sorts of important data and labels around it. And of course, each element within the images can have a lot of interesting information as well. So this is a very useful and interesting application of machine learning systems. So in this example, you can see that it has some sort of deep neural network operation that can detect plant organs or specific sizes and width of the leaf and other important information, and it can label them. That can be helpful, of course, for other types of investigations. Usually, a typical first level of digitization comes what looks like on the left-hand side, maybe just with the label and the collection information, not much detail. There might be text around it, maybe in a paper. However, we also want to connect them, and we also want to make them as automated as possible within the digitization pipeline. So these are the sort of services that will be coming along. Again, these could be also very interesting for the digital twin application as well. And to look at the little bit of conceptual elements behind this is one way to think about it. So all this colored box are coming from our data lifecycle and data management plan. Even though here you see in a more layered fashion, you can think of it as a sort of a circular thing. And again, the key is on the bottom, we have the physical realm, and then the digital connected through lots of variety of different workflow and data processing ontology. And our sources of data comes from the collection management system through the digitization process. At the same time, we curate, publish, process, and use all of this data. There are taxonomic data, images, sequence data that coming in, but there's different types of data modeling and ontology that we have to sort of consolidate in a standard fashion to have this thing work. So that's where the fair digital object come in the digital specimen level with the persistent identifier, specific type of metadata, predictable resolution behavior, and make them as machine actionable possible so that, on the top level, you have the linking and enrichment. You can do all those exciting things with that. So this is sort of a conceptual model, but again, thinking about the data lifecycle from the beginning of the specimen. As soon as we digitize, we want to start curating, processing, and use them and create values out of these data sets. We're also looking into specific serialization of this data, JSON and JSON-LD in particular. Of course, there will be options for both humans and machines to grab this data in different formats through our API. This is a simple visualization of one of the JSON transformed into JSON-LD, where you can see on the right-hand side, we're already using some of the data elements from Darwin Core, which is also used by JBIF and other partners. So there are some alignment within that level, but at the same time, we also have our open digital specimen data, which again connects to the digitization pipeline and digital specimen concept. So we're combining some of these things in this representation. A little bit more detail about the digital object. So this is an example of what we call an annotation digital object, and some of the data model element we borrowed from a W3C concept. So on the top, you see the PID, the handle for the annotation object, but this annotation object is actually connected to a physical object. So basically, the arrow pointing to the target in annotation W3C model, target is basically the thing I'm annotating about. So here, the specimen has been digitized. It has its own PID. I go in either as a human or a machine, and I do some sort of annotation. In this example, my annotation is a quality flagging. You can see here the motivation of the annotation, which is again coming from the W3C model. And then I provide some sort of details, either comments or text about what kind of quality flagging is this. This could be a comment, this could be an error connection. In this case, I used a data quality check from a community standard, and I have a link to that, and I have some sort of scoring for that. And then the W3C standard also tells how to capture who did what. So they have a separation between a creator and generator. And of course, we want to capture the time stamp as well. So this is a very simple example. We're still working on the details of that, and we'll have some demo in a conference soon about this. But the whole idea is that this connection between the annotation PID and the digital specimen PID should be connected. So I can point to this, go here also from the annotation PID, I can find out which digital specimen is related to. And in a way, this annotation could be also sort of a provenance, even though this is not the provenance data model, but you can also figure out from this who did what, when, and why. So that's also important for some of the workflow and processes. This is also an example of the detail of the digital specimen, because that's a different data model. Again, the persistent identifier. MIDS is a standard we're working with for the minimum information of the digital specimen. So there's a way to calculate the number, the version of the PID when it was created. We're also working with the different types of specimen, because as you can imagine, all these billions of specimen spans in different domains. So each of them might have different types of metadata. Of course, the local physical specimen ID, the name, this could be a scientific name for a biological specimen, but this could be also a rock or mineral. And of course here, this is the raw ID I mentioned before, uniquely identifying the organization with the identifier. And then from here, you can also find out more information about that. And there are original data that we harvest that could come from different sources. Here we have Darwin Core information, probably coming from the collection management system that we harvested this information. So again, idea is using this persistent identifier as an anchor, so we can do operations like this, either through human or machine agents. Okay, so I think this is my last slide, just to keep you updated about some of our upcoming events. There's a conference happening in Sofia. This is the Biodiversity Informatics conference called TEDWIC. We'll be presenting about our work on the persistent identifiers and the annotation system, but we will be also talking about some of our output of the Bicycle project, where we're working with Elixir and a few other research infrastructure, LifeWatch and GBIF, to connecting the dots between specimen sequences and literature and taxonomy. We will also have presentation from two national initiatives, from DISSco Flanders and DISSco UK. They will talk about how regionally they're working on similar things with the regional partners, but also at the same time thinking about the European landscape. And then in Leiden, also later this month, we have a conference on the fair digital objects. Again, the fair digital objects is a core element for our infrastructure. And IDAs also will be used in digital twin BioDT as well to think about data interoperability. So we'll have two presentations talking about the data infrastructure and connections of FAIR data. And we're also working with GBIF, DISSco and DataSite, potential pilot to look at, again, those PIDs that I showed earlier. But at the moment, these are Handle, which is similar to DOI, but different type of PID. And we want to use these systems and use this metadata to create DOIs, but with the help of GBIF and DataSite. And the target is to register millions of these digital specimens as a pilot and see what are the problems and what kind of feasibility issues we have. So that's will be coming up. You'll hear about that more on that soon. Yes, I think that's my presentation. Thank you.